So again, I'm sorry I couldn't be with you in person to show you the fly system, but here we are. So today we'll talk about the fly system, the parts and pieces, and the operation of the fly system. So the fly system is the way that we can raise and lower scenery, curtains, electrics, Sykes, and all kinds of things. So we can even add, if we want to, like drops and things like that. And we can raise and lower those drops in and out of view of the audience as we need to. So the fly system is a really critical part of the proscenium theater, which is what we're in today. So behind me is all, of course, the control ropes for how we raise and lower things, which we'll go over in this video sequence. And we'll also talk about the safe way to do that. The counterweight fly system is basically a giant teeter-totter. So on the one hand, you have the batten. On the other hand, we have the arbor. And our goal is to keep the batten and the arbor equally balanced so that we can control them safely. If we don't keep them equally balanced, then we can have a runaway situation. The first part I want to show you is the batten. The batten are the steel pipes that run all the way down across from side to side in the theater. And in our theater, there's 39 of these bars, or 39 line sets. So this bar is it's called a batten in the theater. And we have, each batten is comprised of an 1.5" Schedule 40 pipe. So 1.5" Schedule 40 pipe is sort of like the go-to pipe for us in the theater. We use it for the battens, we use it for special rigging, for lighting, for trees, for dance. So in the theater, Schedule 40 1.5" pipe is ubiquitous. You're going to run into it in pretty much every theater that you'll work in when you leave Cuesta College. So all of our line sets or all the battens of our line sets are all Schedule 40 1.5" pipe, or 1.5" Schedule 40 pipe, depending on how you want to arrange the words there. So, so the battens are what will be holding the scenery, or it could be holding curtains, or cycloramas, or backdrops. And this is where the cable meets the batten. And there's a couple of terms I want to go over with you, some parts and pieces of that connection. First of all, starting from the top, there is these cables. These cables are galvanized aircraft cables, or GAC. They're special cables that don't corrode, which is really important in a fly system. You don't want to have cables that will rust and then fail and then drop heavy objects on people's heads. Doesn't really go over real well for administrators and technicians or actors and performers alike. So we got the 1/4" galvanized aircraft cable. We're not going to use something smaller. We're going to use the 1/4", not like an 1/8" cable, which we use for smaller pieces of scenery. That cable comes down. In our case, there are 6 of these cables spread out over the thing, and these 6 cables are called lift lines. So the 1/4" GAC galvanized aircraft cable is the lift lines. Down here you'll see the termination. We call it termination. How does that cable terminate? In this case, the cable is going to terminate in this Nyco-Press sleeve, which has been crimped 3 times in the middle and the bottom and the top of that. And then there's a special gauge you can check and make sure that indeed you did crimp that quite enough. That connection will, unfortunately for us, because anytime you terminate a cable, will weaken that overall strength of the cable. But we're trying to minimize that by the kind of connectors. And this kind of connector is a little less destructive than other kinds of connectors or terminations. The cable will then go around through this piece here called a thimble. A thimble is basically a steel ring that forces the cable to bend around that radius before it terminates. And that's really, really important because all the weight that's on that cable, if it wasn't for this thimble right here, then what would happen would be that the cable would smush right under the weight, and it would create a tighter turn, and the wire in that cable from the tighter turn would start to fray and break, and the cable would be weakened and it could possibly fail. So this thimble keeps the radius of that cable safe so it doesn't squish and crimp. The cable is then connected to trim chain. The trim chain is a way for us to trim the overall batten. So the batten is pretty long. In our case, 55 feet of batten we have. And there are 6 lift lines. And so if all these links aren't if all these lift lines aren't the same length, then the batten will do like this. It will swoop down and it will kind of create like an uneven batten, basically. It's bending like that. So the trimming allows us to use this connection down here to decide how many links. So that, let's say this point is a little lower than the other points along the batten. It's not level with the floor. We could take this shackle off and then move it up a link and then trim the batten. So that's why it's called the trim chain. We trim the batten so that it's level with the floor. So that in our case, we have it connected by the shackle. The shackle is this piece of hardware right here. It's basically this big hoop right here that's rated for this purpose, rated for overhead lifting. It's not just like a run-of-the-mill, go down to Home Depot and get a shackle. It's a special rigging piece of equipment here, or hardware, I should say. The shackle then screws through here onto this side, and then we mouse it. Mousing it means that we take a piece of wire, we run the piece of wire through that hole, and we connect it back to the shackle so that this pin will not, over time, rotate, fall out of the shackle, and then compromise the fly system. So all these pieces will go up to the grid, which I'll show you like that. And eventually, those will go over pulleys. Except we don't call them pulleys in the theater, we call them loft blocks. So in the rigging system, instead of using the word pulley, we'll use the word block. Once again, that's because of these shipping terms. So, I forgot to mention that, so I should go ahead and pick that up. So in the beginning, when we were starting all of this, the fly system didn't used to be this complicated system of cables and battens and counterweights we'll see later on. It was battens for sure, but it was ship's rigging. So when they started to do flying in the Renaissance, for example, they didn't have counterweight fly systems. So they would use spot rigging, and they would use hemp rope, and they would tie the hemp rope to battens, and they would use ship's rigging, literally. Like, they didn't have that technology, so they'd go out and they'd purchase the ship's stuff. Like the batten is a shipping term, and the block is a shipping term. So that's kind of where those terms come from today, even though we don't use ship's parts anymore for this. So that's going to be called the loft block above us. And we have 6 loft blocks for each line set because there are 6 lift lines. So those will go up. So here we are on the grid. So I had to climb up 60 feet to get here. I'm a little winded, but I think I'll survive. So there you can see the 1/4-inch galvanized aircraft cable connected to that batten right below us. And if I follow that cable up, it comes over to this pulley called the loft block. So there it is, going through the loft block. And there's all the loft blocks for these battens in this one lift line section there. And you take all that and you multiply it by 6 because there's 6 different places. And so you come up with a whole lot of blocks. And all those blocks are then going to feed the head block over there. And the head block is going to be a multi-groove pulley that accepts all of these cables. So we'll try to get in there a little bit like that. And you can kind of see the head block right there. And there's all 6 cables. And also you'll see a white rope in the middle of that. That's the control line. That's what's going to allow us to raise and lower the arbor, which will then raise and lower the batten. So behind me is the loading rail. This is the loading rail is where we add the weight to the arbor to balance the line set. So when we do that, the batten will be all the way to the floor. And because it's like a teeter-totter, with the battens all the way to the floor, then the arbor is going to be all the way up to the top. So we have to actually climb a ladder to get to the top to then add or subtract weight from the arbor to balance the battens down below us. So some arbors don't have much weight on them. This particular line set only has, looks like, it's batten weight. So you see those two counterweights that are painted blue-green. Those are what's called batten weight. So if we were to empty the batten and there was no load on that batten, that weight there, that 50-pound brick plus the 25-pound brick for 75 pounds would counteract the weight of the empty batten and all the cables that are using this system. So in this case, we have a 50-pound item that's on that batten because it's a 2-inch counterweight, and 2-inch counterweights weigh 53 pounds, and we just rounded out to 50 for easy math. So in this case, this batten has 50 pounds on it, plus the batten weight. Then we look at something like, let's look at the First Electric. The First Electric has a lot more weight on it, and the batten weight of the electric is, I don't even want to count all that, but well, I'll just do this and you can count it yourself and let me know how much it weighs. So that's just all of that is just the weight of the cable tray and the two pipes that make up the truss system. So this is how much that electric weighs when it's empty. And then this is how much weight is on that. I'm going to back up here, hopefully not too far and fall over the rail, but that's how much weight is on that particular electric. So quite a bit. So we go from a little bit of weight to a lot of weight in a hurry. To make sure that we don't put too much weight on the system, down here, the company that installs it will give us a placard describing how much each line set can hold, the maximum allowable load on that, and the electrics, as you can tell, can hold a little more weight than the standard battens. So electric is an example of a dedicated line set. Okay, so, and also tells us the weight of those bricks or counterweights or pigs, depending on what slang you want to use for those heavy weights. The 1-inch ones are 26 pounds and the 2-inch ones are 53 pounds. So we're back at the stage level and we're taking a look at this arbor in more detail. So that's the top of the arbor. That's the top of arbor number 8 and arbor number 9, and then here's the bottom of arbor number 11. So that's the bottom. So basically it's a big plate. Through the arbors go these rods called the arbor rods. Let me get in here where on these ropes can see better. So right here is the arbor rods. The arbor rods are what holds the weight in. So here's an arbor rod and here's an arbor rod. And these two arbor rods will hold the weight. You'll notice the weights are notched. So if I get over closer, and there it is. And the notched weights will fit between the arbor rods and then not fall out. And then you'll see over here, you'll see this plate. So this plate here holds down the weight. So you actually tighten that to the arbor rod and to secure, we call securing the weight. So we've secured that arbor. There's all the weight in that one. That's quite a bit. You'll notice these metal pieces right here. In fact, let me go ahead and open this up for us. And we'll take a look at that in more detail. So you'll see these plates. These are called spreader plates. And the purpose of the spreader plates are to hold the arbor rods together in the event of a runaway. So if we have a runaway, what will happen is that the arbor will come crashing down if it's arbor heavy. And when the arbor hits the floor, the rods will spread apart and dump all the weight. And then also now it'll be batten heavy and it could go the other direction. So these pieces of metal are held between these stickers versus spreader plate here. Every time I add more weight, we add more weight, add more weight, add more weight, we drop into those plates. So the plates become like a ladder on the arbor. So now we're walking in the pit down below, and down below the pit we have what we call the tension pulleys or tension blocks. They're below the weights. It's what the control line goes around to go back up again to attach to the bottoms of those arbors. These ones are self-tensioning, which means that as the ropes get loose, these blocks will, through gravity, will find their way down to keep tension in the rope. So that's kind of handy. In the old days, you would have to actually unbolt all those blocks as the tension got slack in the ropes and have to readjust the tension in it and then bolt it back down again.